Good evening, little people in my computer. Today, I'm just going to be giving you a basic tutorial of some of the really simple functions of Inochi2D. I'm not going to be teaching you how to make it look pretty or how to do much of the rigging yourself. That's already a billion tutorials on YouTube and Twitter for that. So for now, I'm just going to be giving the rundown on some of the basic stuff. There is a Discord that I will link, run by the developers, and it's got an active community. Any technical questions you have more advanced than this, check the support channel of this server. And I'm sure the question's been asked before. You'll find answers for everything. Okay, and quick note, this model is based on one of my friends, Super Strawbear on Twitch. So go check him out. He's a really cool guy. So the first step, you want to import your Photoshop document. So you move up to the top, File, Import, and then Photoshop document. Now, depending on what program you actually use to create the Photoshop document, you might crash the program depending on the color space they use. For example, the default Corel Painter version of the PSD saves into a different color space. So if you're getting a bit of crashing when you try to import your document, try loading it into something like GIMP and it will prompt you to change the color space. And that fixed the crashing issue for me. Okay, so now that we've got our puppet loaded in, or all of the pieces and the parts, you need to organize them, and mostly that involves creating folders the same way you would do in Photoshop. So I've got the neck and body in one section of the puppet, then head, face, and the hat. The face then has facial features, the mouth, the eyes, etc. And the rest is just the base of the face. And when you do this, you want to organize them depending on how you want to use these. So if you right click, add, you use a node for things that you're not going to deform. And if you want to deform the whole thing as a group, use a mesh group. So for the face, I don't plan on deforming this entirely. So I filled it as a node. And the pieces inside the face, that being the actual pupils on the eyes, these are made with mesh groups. Okay, so with everything organized, I'm going to go over the basic transform functions. These you can do on almost everything, which is most importantly going to be the only transforms you can do to a node. So you have basic translation. The first field is the X, and the second field is the Y. It's important that when you move these, if you're typing and you just backspace and leave the field, it won't go back to what the value was before. So use Ctrl Z when you want to reset these after you've played with them. Rotation is as it sounds. The first two rotate in 3D space. The last one is relevant for us, looking at it on a 2D plane. So if I want to rotate this clockwise, you add this to 90 degrees, and you end up with a rotation. You can go more or less. Now, the second last part of the scale. This is the X and the Y respectively. You can make it wide or thin, and leaving it at 1 is the default. And finally, the sorting determines how many other parts are in front of it. So as you can click through, you can see these are all labeled. Depending on your program, these might be positive or negative. Alright, so let's go over the different ways to create meshes. For this pupil, we select the part, go down to Edit Mesh, and now we see this screen. We can just grab everything and delete them. The first tool I'm going to show you is the Grid Vertex tool. You click click and hold, and you get a box or a pane with points at regular intervals. You can double click any point on one of these lines to create a line perpendicular to the one you click on. And you can drag these around and fit them roughly to where the edges of the object are. That will do for now, since I'm not really planning on deforming this much. And then for the lash, I will show you how to manually do them with the vertex tools. So we can grab all of our points up here. And just for the sake of this, I'm going to show you the easiest way. So this is the vertex tool. You double click to create points. And I'm just going to throw points at regular intervals throughout this lash. And then I'm going to do them around the outside. And now we fill it in with the edge tool. And to do this, you click on one point and another point. The important thing when you do this is that you always make triangles. If you have a four-sided shape, it's not going to save. So attempt to make as many triangles as possible. So in the case of two areas here that aren't enclosed, they will just not show up. So if I save this and apply the mesh, you'll see that parts are missing. This is the part that we deliberately left out, and this big chunk is where I didn't make triangles. So I'm going to go in to finish this mesh. And what probably happened, I left this angle like that, and there's a big diamond. So I'm going to close this up, go back to the vertex tool. I'm going to confine these a bit closer to the actual mesh. So there are two more ways we can do this. The first is we can manually add mesh points and then turn on triangulate vertices, and it will automatically draw lines between your points. But we can also use this button up the top, and this auto meshes to its best attempt. You might need to clean it up for this part's hanging out of the mesh and it will get cut out. But for the most part, this is usable. Alright, I had to move over a little bit here. So next we're going to go over masking. Basically, I want all of these parts of the eye to only show when they are overlapping with the whites. So essentially, I'm going to grab each of these parts that I want to be masked, and then I grab the layer that I want them to be masked to and drag it into this mask sources section. And now you can see that gets cut off where the white is. You can switch this to dodge mode, and that's the opposite. It will only show if it's not overlapping with the mesh of the object in the sources. But I'm going to leave that on mask, and for the rest of these sections of the eye, I will mask them to the base. Okay, so now we're ready to animate this eye. So for this parameter, since blinking is a binary, you're either blinking or not, we're going to do a 1D parameter from 0 to 1. And now, to work with this, we need to arm the parameter and move it from its open state to what will be its closed state. And for this, I'm going to be closing the whites of the eyes. This is not the cleanest way of doing it, but I'm going to do quick and dirty just to get the point across. Select and grab a bunch of nodes and then move them down. And see how the rest of the layers are disappearing because they are masked to the base of this eye. Next, I'm going to grab the lash and just move the whole thing down. You can do that by moving the area in the transform panel or by moving it down using these controls in the display. I'm going to move all of these pieces into a relatively flat line and use this to cover up the whites. Now I'm going to grab the group for the entire eye socket and I'm just going to translate this up a little bit so it looks more natural. And now we have a very basic, very janky blink animation, and essentially everything works under that principle. Alright, so next is 2D parameters, and these will be the movement of the head in the XY. So let's add a 2D parameter from -1 to +1, since you can turn left and turn right. And this is essentially the same thing, but on multiple axes. So if I arm the recording, and then I turn to the left, I can grab the face and translate the whole thing to the left. I can then move it to the right and translate the whole face to the right. While doing this, I can also grab various other parts. So the snoot of the hat will move to, the snoot of the hat will move to the right, whereas the back of the hat will move to the left, and each wing will move closer in on the face, and vice versa. So the lion's snoot will move with the face of the snoot of the hat will move back, and each wing will respectively move tighter in on the face. And now we have basic XY movement. We can do the same for up by moving the actual face up. We can do down by translating it all down. And then the hat, the snoot, will go down, while the face will go up, since it's on the back of the head. And vice versa. The back of the head will go down, the snoot will rise up. So now we have basic head XY, just to replace the snoot and the lion's head with the front of your hair and the back of your hair, any ponytails. Alright, so if you wanted to form a bunch of things, I'll show you the mouth. The mouth is a mesh group. So, for example, this funnel parameter is determined by how narrow your mouth is. So or, or, or. And if I wanted, I could use this mesh group to change both. So let's say I want my eye blink. I'm just using the eye blink parameter as a demo. To make this shorter, I can deform both the mouth and the tongue part to move together. And what that is doing is each movement of these nodes will move the corresponding node in both the mouth and the tongue. The nearest node will correlate with the nearest node in the mesh of the mouth mesh. So, let's just pretend we want this guy's mouth to jiggle. First things first, we need to add a new parameter from -1 to 1. This is going to be our physics parameter, so I will name it mouth wobble parameter. Now, I will add a physics node, and since this is going to be on the mouth, and since the mouth moves with our face movement, I am going to grab the mouth node, add simple physics. Alright, so I'm going to grab that simple physics and name it and you will notice that it has a pendulum. Since it's part of the mouth, which is part of the face features, which is part of the face, it will move with the head, and therefore you will get wiggle. So if we, while mouth physics is selected, grab the parameter, mouth wobble parameter, and drag that into this section of parameter in the physics, keep an eye on this little section, it will wobble. If you want it to wobble more, you can multiply the output scale and you can reduce the dampening. So this will now wobble a fair bit. Now we go into our wobble parameter, arm it, and we make the changes that we want to apply. I'm going to apply these to the back part of the mouth because it is masked to the tongue and it would be weird for the tongue to move. So we grab the mouth back and in the left position, we're going to translate the mouth to the left. And let's also squish the x-axis a little. Then we'll move it to the right position and do the same thing. So now, when we let go of the arm and we move the face around, the mouth will jiggle. So that is how I have done almost all of the physics on this model. On top of that, when doing vertical physics, it's a little trickier. So I actually, let's grab the Y physics for the snoot. When I move this up and down, you'll notice the physics node, since it's not attached to a moving body part, can be automated by itself. So this is just moving left and right, making the pendulum move, and then I have that left-right pendulum movement applied to up and down on the nose. So if we were to do that with the mouth, we would add a new parameter, 1D, name that mouth wobble Y. And I would create on the puppet, so the parts that don't move, a simple physics node. And I will name this simple physics node mouth wobble Y physics. I will drag the new parameter into the parameter. And then, as part of my face's XY movement, so this is the XY we made ourselves. When we move up, I will arm it, and then when we move up, just move this physics section to the left, because up is technically negative. And then when looking down, we'll move it to the right. So when we move this up and down, the physics node moves side to side, which makes the physics of the mouth wobble move. We can then arm that. For the left, move the mouth in the left position. That means because it's negative, it will move upward. And I will also compress. And then for the positive, we will move it down, and I will also compress. So now we will effectively have up-down jiggle. It's not particularly bouncy, so let's go into that. Turn up the output scale, turn down the dampening, and we should get a bouncy mouth. Okay, so now I'm going to show you the bare minimum parameters that you'll probably need and which parameters you should do for them. Each eye will require an XY parameter. It will also require a blink, and it's a good idea to bundle this with raising that side's eyebrow. Then, for the mouth, I have 4 parameters bundled. This is a smile 2D parameter, which affects the eyes a little bit, whether the mouth is open or closed. The mouth funnel that I explained earlier being the narrowness of the mouth when you make an ooh sound. And then this one's technically nose tracking, but I like it for controlling expressions, so that's sneer. And to get another point along your axes, you click the settings, edit axes points, and then you can add a new point. So this first point rotates the mouth into an upside down position, which looks upset. And then as it goes on, the eyebrows arc up more and the mouth gets more distraught. Then the head roll, which is essentially rotating on the neck. Okay, so that's pretty much the basics of what you can do. There are a few extra things like 2D physics and path deforming that are kind of complicated and that you don't really need for doing basic stuff. So I will upload a new video at a later date when I actually understand how to use them, and I'll explain them a bit better. But this should be enough to get you into it. From here, you should check out YouTube and Twitter videos on how to actually do the rigging. So head XY tutorials are very, very useful. That's the hardest part. There's also a bunch on how to do mouth shapes that, again, I didn't want to tackle, so I just did 1D parameters. But the standard operation is to use a very complicated mouth shape. For basic practice, I recommend just going with parameters until you can learn the basics. Then you can move on to mouth shapes. Anyway, good luck out there. Hope you all have fun. Definitely check out the Discord of the creators. I'll link it again below. Super helpful, great community. Love them to bits. So thank you, Luna, for making this awesome project and for everyone who's contributing. It is a lot of fun.